In these notes, I'd like to teach you how to do stoichiometry. All right, so I'd like you to do these notes on the right side of your notebook on page 7. On page 6 is where you can do some of the examples. If you run out of room on page 6, I don't want you to use another page in your notebook. Rather, I'd like you to use some loose leaf paper, extra paper that's not in your notebook. That way we don't waste the pages in our notebook. All right, let's get into stoichiometry. Okay, so stoichiometry, what it does is it allows chemists to see the relationships between reactants and products. So the application of this is if you know the amount of a reactant in a problem, you then can predict how much of that product you will make. All right, push pause if you need a moment to write that down in your notes. Other than that, we're going to move forward with the different parts that you're going to need to do some gram-to-gram stoichiometry. So in gram-to-gram stoichiometry, you will always need the following numbers. There's 4 numbers that you'll need. If you ever are wondering, I'm doing this wrong, well, it's probably because you don't have the 4 numbers that you need, and it's always the same 4 numbers. It's just that the numbers are different, if that makes sense. But it's the same 4 types of numbers. Okay, so the first number that you're going to need is a starting mass. In every gram-to-gram stoichiometry problem, it'll say, I start off with 20 grams of so-and-so, or I have 150 grams of blank. The starting mass is your number 1 number. Where does this come from? It comes from the word problem. All right, the second number that you need for gram-to-gram stoichiometry is the molar ratio. I made another video available on YouTube on how to determine the molar ratio. Basically, you're going to use the coefficients of a balanced chemical equation. Those numbers in front of a chemical equation, those are in moles. I'll show you what that looks like on the next slide. So where does this come from? It comes from the coefficients of a balanced chemical equation. All right, and then you're going to need 2 molar ratios. So the first number is a starting mass, the second number is a molar ratio, and the last 2 numbers that you need for gram-to-gram stoichiometry are 2 molar masses. I also made a video on YouTube on how to determine molar masses. Where does this number come from? It comes from the periodic table. You're going to add up the atomic masses of each of the elements that you care about. In a lot of these gram-to-gram stoichiometry problems in the balanced equation, there might be 4 or 5 different chemicals that you care about. You only, though, need to get the 2 molar masses of the chemicals that the question asks about. In the next example, you're going to see what I'm talking about. All right, so what do you need to review? You need a starting mass, you need a molar ratio, and then you need 2 molar masses. And if you have those 4 numbers, you can do gram-to-gram stoichiometry. Let's see what some of these numbers look like in a real live application practice problem. All right, so imagine I've got some HCl and zinc. Hydrochloric acid plus ZN zinc will react to form ZnCl2 and H2 gas, zinc chloride and H2 gas. This is not balanced, and so I need to put a coefficient in front. I see that there's 2 Cl's on the right and 2 H2's on the right. I see that there's 1 H and 1 Cl on the left. So I'm going to put a coefficient of 2 in front of that HCl, and now we're balanced. Done. All right, let's see. We're going to need a question. If I start with 10 grams zinc and place it into an excess amount of HCl, how many grams ZnCl2 will I make? The elements that I care about, or the compounds that I care about, are zinc and ZnCl2, zinc chloride. All right, we're going to need a known and unknown table. As always, I always start with what I don't know, so I go to the part of the sentence that has the question mark in it. All right, it says grams ZnCl2, so that's what I want my final answer to be in. Let's take a look at what we do know. The first thing that we know, hey, there's that starting mass that I talked about in the other slide, 10 grams zinc. So that's something that we know. We're going to write that down. All right, what else do we know? We know that we care about zinc and we care about zinc chloride. And so now I need the molar ratio. I'm going to go up to my balanced equation. I'm going to look at the coefficient in front of the zinc and the coefficient in front of the zinc chloride. Why don't I do HCl or H2? You know what? Because the question doesn't ask about it. The question is asking about zinc and zinc chloride. So those are the numbers I'm going to use. There's no number in front of the zinc or the zinc chloride, so we just assume it's 1. All right, hey, it's a 1-to-1 molar ratio. That's an easy one. So there's 1 mole of Zn for every 1 mole of ZnCl2. The last two numbers that we need are 2 molar masses, and that comes from, well, zinc and zinc chloride. So the molar ratio, the molar mass of zinc is, according to the periodic table, 65.36 grams zinc per mole zinc. Notice how I am labeling all of my units. I do not want to just put grams over mole. It's grams Zn over mole Zn. If I label my units, I'll be better able to solve this problem. All right, the other molar mass comes from ZnCl2. I'm going to add up the atomic mass for zinc from the periodic table plus 2 chlorines, 35.44 plus 35.44, and you get 136.24 grams zinc chloride over mole zinc chloride. All right, we've got our 1, 2, 3, 4 numbers, and we're ready to solve the problem. Let's do it. I'm looking for grams zinc chloride, and so what I do is I come over here and I find it in what I know. There's that unit. It's on top of this fraction, so I don't need to flip it or anything. I'm just going to write out 136.24 grams ZnCl2 over mole ZnCl2. There it goes. All right, now I've got to cancel out that mole ZnCl2, and I can do that. I'm going to multiply it by, hey, how about the molar ratio? But notice how the mole ZnCl2 in my molar ratio is on the bottom. I need to flip it because I want to manipulate the number so I can cross out and cancel out mole ZnCl2. So I'll flip it, turn it upside down. Put 1 mole ZnCl2 over 1 mole Zn. All right, I'm going to have another multiplication fraction. Now I need to get rid of that mole Zn on that recent fraction I just wrote down. So I'm going to come over to what I know, and I'm going to look for that unit. Hey, there it is. It's on the bottom. So I'm going to flip it. Why am I flipping it? Because I want to be able to cancel out that unit. So put mole Zn over 65.36 grams Zn. Now I want to cancel out gram Zn, so I come back over to what I know. There it is. And if I multiply that by 10 grams Zn, everything's going to cancel out except for that first original unit. Let's cancel some stuff out. So mole ZnCl2 over mole ZnCl2 cancels, mole Zn over mole Zn cancels, and gram Zn over gram Zn cancels. All right. Order of operations says that I've got to multiply everything separately before I divide, and so I'm going to multiply 136.25 grams ZnCl2 times 1 times 1 times 10 over 1 times 1 times 65.36. Order of operations says multiply those first. Done. Over 65.36. Now I'm going to work from the top down. Put the top number, divide sign the bottom number, and I get a final answer of 20.8 grams ZnCl2. I'm going to make another video here with another example so that you can watch that. It'll be shorter, trust me, but this is the concept that you're going to need to do. Guys, it's the same every single time. In fact, the order of the 4 fractions is always the same, no matter what. It's just that the numbers and the chemicals change. It's always the same, though. And the only way to get really good at this is to keep practicing it. Watch the video again. Redo it. It takes a long time, right? Use up a lot of space in your paper, but do it. It's how you do it. All right. There's no other way to do it other than to practice. Okay, I'll talk to you soon.